Hi you guys. So this problem that we're going to do next is problem number 50 from chapter 4 from the section on mesh currents. So first let's talk about the circuit. We have a 19 amp independent current source here, a 40 ohm resistor, 5 ohms, a current controlled dependent current source of 2 IB. So this current source is controlled by the current that goes through the 5 ohm resistor. So we got a 10 ohm resistor here, a 240 volt independent voltage source, a current controlled dependent voltage source with value for ID. So it's controlled by the current that goes through the 240 volt independent voltage source. We're looking for the branch currents IA, IB, IC, ID, and IE. We're looking for those branch currents in part A. In part B, we're going to prove that our answer is right by showing that power dissipated equals power developed. Okay, so we want to, first of all, you need to know what a mesh is in order to do any problem or any mesh current problem. So a mesh is a connection of circuit elements that where the beginning point is the same as the ending point. For example, this is a mesh. This from here, 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 here. That's a mesh, and it actually is an essential mesh because there are no other circuit elements contained in that closed loop. This is also a mesh. 1, 2, 3, 4, 5, 6, 7. That also makes a mesh. But it's not an essential mesh because inside that closed loop is a circuit element. Okay? So the mesh current method uses KVL, Kirchhoff's voltage law, and it says the sum of the voltage drops around a closed mesh is 0, but that only applies in 2 cases. Case 1 is the essential mesh, and the second case we'll talk about in a second. So this here, this second mesh that I just showed you, is not an essential mesh because it contains a 40 ohms resistor circuit element inside of it, and therefore KVL will not hold. So it has to be an essential mesh. That's condition 1. The only time that KVL or the mesh method will work with when you have a non-essential mesh is in the case where you have a current source. Then it makes a super mesh. This is a mesh that's non-essential. So this is a non-essential mesh where KVL will work because the circuit element inside the mesh is a current source. So this is a mesh 1, 2, 3, 5, 6. So it's a non-essential mesh because inside this mesh is this current controlled dependent current source. So the reason why KVL will still hold if you just, in this case, is if you treat it like you removed it and then just went around the voltage drops here, is because we're going to demonstrate this when we do the problem, that when you when you have a mesh here, you're going to end up canceling out the current source, so it becomes a non-factor, which is why KVL will hold on the outer loop. Okay, so we're going to demonstrate how and that's called a super mesh. So that's the only time when you have a non-essential circuit element where KVL will hold is when the border of two essential mesh is a current source will cancel out. Okay, so let's go ahead and get started. We're going to, first of all, we need to name our mesh currents. So this one, I'm going to call, well, I don't need to name it because it's just that 19 amp, right? And I want to keep the naming convention consistent with what I called it the first time so that I can check against my answer. So this is going to be, I called it some IX. And this one I don't need to name because the diagram schematic has already told me this is ID. And I don't need to name this one either because the diagram has told me this is IE. So those are my 4 mesh currents. So let's start writing our mesh equation. So mesh at 19 amp. So that's going to be, well, I don't know what this, so the first thing we have to do is we have to recognize that this current source has some voltage drop associated with it, but we don't know what it is. So we're going to call it Vx. Okay? And the direction of the voltage rise is going up, so the potential is going up, right? So it's going from minus to plus. So that means the first term in that equation is minus 19, oh, not minus 19, minus Vx. And the next term is going to be, the next voltage drop is across the 40 ohm resistor, and that is going to be plus 40. So V is equal to IR, the R is 40, the I is a net current of 19 minus Ix, and that's going to equal 0. Now, let's go ahead, I'm just going to go ahead and multiply everything out. So it's going to be 40 times 19. So this is going to be 760 minus 40. So this equation is plus 760 minus 40. 40, so 760 minus 40 Ix is equal to 0. So let's just go ahead and put the 760 on the other side because we're going to do that later anyway. So that becomes negative 760. So we got minus Vx minus, double check. So minus Vx minus 40 Ix is equal to negative 760. Okay, that's equation number 1. All right, so then we're going to take mesh at Ix. So the first voltage drop is the voltage drop across the 40 ohm resistor. So 40 is the R, the I is Ix minus 19. And the next voltage drop is going to be across the 5 ohm resistor, so that's going to be 5 times Ix minus IE. And then so this is where we have a super mesh. So in order to demonstrate why a super mesh works, let's pretend we don't see the super mesh. So we say there's some voltage drop across here, Vy, right? The direction of the voltage rise is in that direction, so we're going from minus to increasing potential. So then we're going to say it has some Vy. Vy is equal to 0. Okay? So let's simplify this. 40Ix minus 760 plus 5Ix minus 5IE plus Vy is equal to 0. So I'm going to start combining terms here. So 40Ix plus 5 is going to give me 45Ix. And then on this side we got positive 760. And then so Ix minus 5IE plus Vy. Okay, double check. 45 minus 5IE is equal to, okay, good. So that is mesh at IE. Now let's do mesh at ID. So now we're going to start on this side, and we're entering, the current's entering the negative terminal, so we got negative Vy plus, so the next one is 10, the next voltage drop is across the 10 ohm resistor. So that's going to be V is equal to IR, the I is 10, the R is 10, the I is ID minus IE. And then this voltage drop, the current is entering the negative terminal, so it's going to be minus 240 is equal to 0. So let's simplify this one. So we got negative Vy plus 10 ID minus 10 IE is equal to, let's bring that on the other side, to us 240. And no terms combined. So that is as simplified as get. So here is why the super mesh works. The reason why it works is because In algebra, we can add any two equations together that we feel like. So if we add this one together with this one, we'll come up with one equation that says 45ix minus 5ie plus vy, right? That's that equation. And then, so then right here, we're going to add on this side, we're going to go minus vy. So we got minus vy plus 10id minus 10ie is equal to 760 plus 240. So what happens then is you have a minus vy plus vy and a minus vy. So it ends up that when you have a current source that borders two essential meshes, the voltage drops cancel each other out. And that's why a super mesh allows you to just go around and just ignore that voltage drop, is because you'll always end up canceling each other out when you do the two meshes. So that's why it works. But let's just go ahead and do it this way. So we got our next equation is minus vy plus 10id minus 10ie is equal to 240. I take okay, well that's fine, whatever. I was gonna do the super mesh, but never mind. All right, so that's mesh at ID. Mesh at IE. Mesh at IE is we're going to start at the 5 ohm resistor. So we got 5. Voltage is resistance times current. So the resistance is 5. The current is IE minus IX. And the next voltage drop is that current controlled dependent voltage source. So it has value of 4ID. It's kind of weird to see a current term that represents a voltage, but that's a place where you can really make mistakes. Always be aware of what you're doing. You're adding voltages, and that's a current controlled dependent voltage source. The next voltage drop is across the 10 ohm resistor. So that's going to be plus 10, that's your resistance. Your current is a net current of IE minus ID. All that is equal to 0. So let's simplify this one. It's 5IE minus 5IX minus 4ID plus 10IE minus 10ID is equal to 0. So then we got 10IE, 5IE and 10IE, so that's 15IE. We've got negative 4ID and negative 10ID is minus 14ID, and minus 5IX is equal to 0. So that's our fourth equation. So let's replace that with our fourth equation. So we got 15IE minus 14ID minus 5IX is equal to 0. Take a second to check my equations. 15 minus 5IX minus 4ID. Okay, now we have a problem. We have how many unknowns do we have? We have Vx, Ix, IE, Vy, ID, IE. We started at IE, IX. So we need, we have, IA, Vx, Ix, IB, ID, IC, IE, and Vy. We have 8 unknowns and 4 equations. So we need 4 more equations in order to solve for everything. So let's go ahead and we're going to get our equations, our additional equations from the constraint equations. So this current, we're looking for IA, right? So we got IA is equal to 19 minus 40. Oh, not 40, but 19 amps minus Ix. Okay, so I'm going to move the Ix over here. So it's going to be IA minus Ix is equal to 19 amps. That's going to be one of my constraint equations. So IA minus Ix is equal to 19. Our second constraint equation is going to be the IB equation. So it's going to be the sum of IE plus IX, or minus IX. So IB is equal to IE minus IX. We're going to put everything over on one side and say IB minus IE plus IX is equal to 0. Okay, so IB minus IE plus IX is equal to 0. So now we have 6 equations. We need 2 more equations. And the next equation is going to come from the current control dependent current source. So that equation is going to be ID minus IX is equal to 2IB. That's that constraint equation. We're going to put everything on the other side. So we're going to go ID minus IX minus 2IB is equal to 0. So let's put that up here. ID minus IX minus 2IB is equal to 0. And our final constraint equation is going to come from IC. So we got IC is equal to IE minus ID. So putting everything on the other side says IC minus IE plus ID is equal to 0. IC minus IE plus ID is equal to 0. Now we have 8 equations and 8 unknowns. So let me just take a second. Oh, IA plus IX is equal to IA plus IX is equal to 19. Okay, I have a problem with this equation. So IA is 19 minus 40. Oops, 19 minus 19 minus IX is equal to IA. So bring the IX over here, so it should be 19 plus IA plus IX. So this should be a plus. IA plus IX is equal to 19. Okay. The next one is IB minus IE plus IX is equal to 0. IC minus IE plus ID is equal to 0. ID minus IX minus 2IB is equal to 0. Okay, great. So now I have all of 8 equations and 8 unknowns. So let's go through and go. We got IA, VX, IX, IB, ID, IC, IE, VY is equal to something. This matrix is so big that I'm going to make a page out of it. Okay, so equation 1, the first equation, we got 45 for IX. The next equation is -5 for IE, and constants is 760. Zeros everywhere else. Okay, so 0, 45. 0, 0, 45, -5. Oh. I need a 1 here for VY, that term. So, 1. Try one more time. 45, 0, 0, 0, -5, 1, 760. Okay, so that's the first equation. So the next one we have, actually I did this number 2 first, so now let's go back and do number 1. So that should be -1 for VX and -40 for IX. So -40, and then constants is -760. Zeros everywhere else. negative 1, 0, negative 140, negative 760. Okay, so that's that equation. Now we're going to do the third one. We got negative Vy. So Vy has a negative 1 coefficient and ID has 10. And then IE has negative 10. And constants is 240. Zeros everywhere else. Double check. 10, 0, negative 10, negative 1, 240. Okay, and then, so now let's do this one right here. 15 IE, 15, negative 14 ID, negative 14, negative 5 IX, zeros everywhere else. I'm running out of space. Well, I am out of space going down, so I'm going to erase this and go up. Okay, so that's that one. So now we got IA, IX, and 19. So let's go up. And we got IA is 1, IX is a 1. Okay. And erase these other equations, make room. Okay. So we got IA is 1, IX is 1, and then constant is 19. And zeros everywhere else. Okay. It's 101, 19. Okay, good. So now, the next one is, we got 1 IB, negative 1 for IE, and 1 for IX. Zeros everywhere else. So 0, 0, 1, 1, 0, 0, negative 1, 0, 0. So that's that one. The next one is ID. So we got 1 ID. So ID's right here. 1 ID, negative 1 for IX, negative 1, and negative 2 for IB. IB, negative 2. Zeros everywhere else. Let's see. 0, 0. 0, 0, negative 1, negative 2, 1, 0, 0. Okay, hang on. I don't know why, I don't know why I have a 1 here. This should be 1 ID, 1, negative 1 IX, and negative 2 IB. This should be a 0. Okay. So that's that equation. And then the last one, we got so the last one we got is 1 IC. So IC is here. 1 IC, negative 1 for IE, negative 1 IE, and then positive 1 ID. ID is here. So we got 0 everywhere else. So that gives me 0, 0, 0, 0, 1, 1, minus 1, 0, 0. That's our 8 by 8 matrix that we need to solve. So go to your simultaneous equation solver. Okay. And 8 by 8. So 0, 0, 0, 0, 1, 1, minus 1, 0, and 0. 1, 1, minus 1, 0, 0. Okay, so the next line is 0, 0, minus 1, minus 2, 1, 0, 0, 0, 0. Okay, actually, you know what? I'm going to let you guys put this matrix in because it's It was a long one. So, but what you should come up with when you do that, and please post if I made a mistake on the matrix, but you should come up with IA is equal to negative 7 amps, Vx is equal to negative 280 volts, Ix is 26 amps, IB is negative 8 amps, IC is 8 amps, ID is 10 amps, IE is 8 amps, and VY is negative 320 volts. So 1, 2, 3, 4, 5, 6, 7, 8. So that's the answer to this big ugly matrix. So the answer part A is IA, IB, IC, ID, IE as posted. And okay. Hopefully I didn't make a mistake, because I just don't have the patience to do an 8x8 matrix on my calculator. But I did double check the values of my original matrix. Okay, so that's the answer. Now in part B, we're supposed to verify those are correct by showing that power dissipated equals power developed. So I don't have the schematic up, but you can look at your schematic. And let's go through and find the power of each one. So there's a 19 amp source. That's going to be minus Vx times 19 amps. So P is equal to Vi. Vx is negative 230. Remember, the current entered the way the voltage rise, the arrow was in the up. So that means the voltage rise is going up. So that's going to be negative voltage. So it's minus, but the Vx is negative. So a negative times a negative is a positive. That gives me 280 times 19. And that's equal to 5320 watts. So the power of the 40 ohm resistor is going to be 40, right? And the I, which is the IA, the only current going through that is the IA, so that's going to be the negative 7 amps squared, and that'll give you 1960 watts. So the power dissipated by the 5 ohm resistor is going to be 5 times IB, which is negative 8 squared, so that'll give you 320 watts. So the current controlled dependent current source, so it's going to be power is equal to voltage times current, right? So VI. So the V is negative 4 ID, so ID is 10, and IE is the current going through it. That's 18 amps. So that gives me negative 720. Actually, hang on one second. No, the current going through it is going to be Ix minus ID. So Ix is 26 minus ID. ID is 10. P is equal to VI. One second. Ix. What did I say Ix was? Ix is 26. 26 minus 7 minus 280. 26 minus 8. ID is 10. IC is 8. IE is up. Here's the problem. IE is 18. IE is 18. Okay. So then, we got VY. So the power of the current controlled dependent current source is VY. So V, the voltage drop across that is going to be negative 320. So, sorry, before ID. Okay, so, sorry, this is, it's hard when I can't look at my schematic on the board, but this is the current control dependent voltage source. So the current, so we got IE, the current through that is IE. So IE is 18, and the value of the voltage is 4 ID. So IE is entering the negative terminal, so that is -4, and then ID is 10. So that should give you negative 720, I think. Double check. So -4 times 10 times 18 is negative 720. Okay, so the next one is the current control dependent current source. So that's going to be VY. VY is negative 720, right? So VY is negative 720, but however, the net current is going in the negative terminal, so a negative times a negative is a positive. So that's going to be positive 320 times IX, or 2IB, so times ID minus IX. So ID is 10, minus IX is 26. 26. So the net current is oh no, I'm being silly. The current is a current source, so it's going to be times 2IB. So 2IB, actually, you know, the other way should work out to be 2IB as well. But the current source itself is controlled by 2 times -8. That should give you negative 5120. It would have worked the other way out, you guys, so that's irrelevant actually. So power of the 10 ohm is going to be 10 times 8 squared. So the 10 ohm has a net current of IE minus IC. So IE is 18, IC is okay. The net current of it has IC going through that, so it's going to be 8 squared. So, but it's a net current of IE minus ID, so that's 8 squared. So that will give you 640 watts. And the final one is the power dissipated by the 240 volt independent voltage source. Well, power is voltage times current, so our voltage is negative 240 because the current is entering the negative terminal. And the current is ID, and that's 10. And that's equal to, that gives you negative 2400. Okay. So, now we're going to show power dissipated equals power is developed. Negative power is power that's developed. Positive power is power that's dissipated. So put all the negatives on one side. So let's go down the list. The 19 amp dissipates 5320. 1040 ohms is 1960, and then the 5 ohm is 320. The 4 ID voltage source gives me 720, develops 720, and the 2 IB dependent current control dependent current source gives me develops 5120 power, and the 640, the resistor dissipates 640 watts. The 240 volt develops 2400. So these two columns have to equal each other. So 720 plus 5120 plus 2400. 720, 5120 plus 2400. So on this side, the circuit is developing 8240 watts of power. And let's see how many it dissipates. 5320 plus 1960 plus 320 plus 640. So it dissipates 8240 watts of power. So power dissipated equals power is developed, and that's our proof. Okay, you guys, remember, if you got free help here, to like the Facebook page, so that your friends can find us, and it can become a more interactive forum. But actually, even better yet, give help when you see a question that you know the answer to. Respond to it and help other people. Give back to the community.